Next section is a Granger causality analysis. Granger causality analysis. Actually, whatever the theory, the journal article, or initial concept or initial theoretical framework, we expect that the X will affect the Y, correct or not? But at the end of the day, after we do the analysis work and the data interpretations, we find out that the Y actually is affect the X. It's not the X affect the Y only. Okay, we call this one as a two-way direction, two-way direction analysis. Not only the X affect the Y, Y affect the X. Can understand? Okay, so definitely we are not going to not for the X and affect the X. We are not going to do this. We only focus on the X affect the Y, and the Y affect the X only. So this will be another section. You can part this one as 4.3. 4.1, 4.2, 4.3, and then we come to the 4.4. Okay, I believe this one not every group is doing. We call this one is a co-integration analysis. Okay, can be Johansson analysis or ARDL analysis. This also same is around 100 to 150 words only. 100 to 150 words only. Okay, that's all for the descriptive analysis. That's all for descriptive analysis. If not mistaken, maybe at least 2 pages. 2 pages. And then we come to the empirical analysis. Okay, this one actually is just like preliminary analysis for our data, correct? We want to see our data characteristic, whether match to the normality or not. Okay, now we come to the empirical analysis. What I mean by the empirical analysis? We have to fulfill the BLUE, Best Linear Unbiased Estimator. Anyone take econometric? Wow, this class no. Wow, surprising. Wow, I thought about econometric, everyone feel really want to take it. Okay, BLUE, they have the assumptions. Definitely they have a lot of the assumptions. But our data is a panel data. We focus on the few assumptions only. The first one is the residual normality test. Okay, normal residue is normal. Okay, binomial curve, I mean the bell curve and so on is some sort like the normal bell curve. Normal bell curve. But I believe due to our sample size, is very small. It's not like the 2,000, 3,000 words. So if not normal, okay, if the residual bell curve is not normal, so you have to justify the reason. Okay, I give the very common reasons here. Maybe the natural data characteristic is not normal. So what we can't do anything correct not? Because the data itself is not normal. Okay, it's from our sampling and it's from the populations. Okay, next we have to run the heteroscedasticity. Okay, if we got the heteroscedasticity, how? So we have to run the panel option Huber-White to solve the problem. Correct not? Once we run the Huber-White already, and then it will pop up this one estimation output. This is our final output. Okay, final output or final EView output lah. Go or not? Have you run?
Yes.
Yeah, this is your estimation output, the final one after the Huber-White. Correct not? Okay, the third will be autocorrelation test. So for autocorrelation test, we are going to take the Darwin-Watson statistic. So we get from the Darwin-Watson here. Okay, this one is your EView output, correct not? So the Darwin-Watson, the figure is from here. Okay, and then you put in the autocorrelations, whether you want to see whether they have the autocore or not autocore. If got autocore, then you analyze. If no autocore, then you also analyze. Okay, but typically our data is there. You just identify lah. If autocore, we also cannot solve the problem lah. Okay, if autocore, then we cannot solve the problem, and why? Why we cannot solve the problems? And then you stop at here. Okay, for the empirical analysis. After that, you have to interpret the R square first, and also F statistic. R square first, after that only F statistic, probability F statistic. Can against I saw someone 皱眉头 which means that don't understand already. First descriptive analysis 1, 2, 3, 4. Okay. Empirical analysis 1, 2, 3. Okay. This W Watson statistic you get from the estimation output here. Okay. This one is an empirical analysis. After that, you analyze about R squared and F statistic. Okay. Okay, finish empirical analysis finish. Okay, now we have to go through each variable interpretations. Okay, each variable interpretations. Okay, example variable x1 what are the things that we are going to look into? Yes, we have to look into the probability first. The first step we have looking into the probability. So you have to interpret each variable probability whether significant at 0.05 or not. This 0.05 can be 0.01, can be 0.1, okay, which means can be significant at 1%, can significant at 5%, can significant at 10%. Of course lah, okay, if you want to get more variables to analyze, this is the minimum 0.1, 0.05, 0.01. Okay, this one is the 1 star, this one is the 2 star, this one is the 3 star. Okay, 3 star which means that very significant, very significant. Okay, so if less than 0.05 significant at the 5%, reject the null hypothesis, accept the alternate hypothesis. So you refer back to the literature review. What is the hypothesis? What is the hypothesis? Okay. If more than 0.05 not significant, accept the null hypothesis and reject the alternate hypothesis. Okay. Up to here, you have to refer to the chapter 2. Whatever the hypothesis you write under the chapter 2. Okay, example, if variables x1 is a 0.05, which means significant, correct now? But it's a positive. Positive, significant, positive. What do you mean by the significant positive? Significant and positive, correct not? So which means that this x1 have the impact to the y. x1 have the impact to the y. So why like this? So you have to get through the theories and journal article to support okay, which you write in the chapter 2. Okay, which means that each variables x1, x2, x3, x4, you also have to do the interpretation. Positive negative you have to get the journal to support. Okay, but it's a good thing, you know. Okay, I erase here.